Today we're going to cover Unit 1, Lesson 2. Lesson 2 is on properties of the real number system. And before we get into the properties, I want to just review a couple things with you that you probably had in algebra, maybe pre-algebra, just some terms that you need to be familiar with. The additive identity element is 0 because 0 is the number that you can add to any number and get that number itself. Okay, so the additive identity element will be 0. Similar to that, the multiplicative identity element is going to be 1, the multiplicative identity element, because any number multiplied by 1 will give us that number itself, its identity. So those two terms you need to be familiar with. Another thing you need to be familiar with is reciprocal. You should have learned about reciprocals when you did division of fractions, because to divide fractions you have to keep the first fraction the same, change your division to multiplication, and then flip that second fraction upside down. A reciprocal is the same thing as the multiplicative inverse. Those two things go hand in hand. They are exactly the same thing. So we'll interchange those terms throughout the Algebra 2 course. Basically, the reciprocal and the multiplicative inverse is any fraction that is flipped upside down. So that's just kind of a slang term for that. But if you have something like 3/4, well, the multiplicative inverse of that, or the reciprocal of that, is 4/3. They are not equal to each other, so we would never put equals, 3/4 equals 4/3. It doesn't. But they are reciprocals or multiplicative inverses. If you have something like 1 and 1/3, well, the reciprocal of that would, you could not say it's 1 and 3/1. That would be completely wrong. You would have to convert that to an improper fraction, which would be 4/3, and then the reciprocal of that would be 3/4, okay? If you have a whole number, something like the number 5, well, 5 is understood to be 5/1, so the reciprocal of that would be 1/5, okay? You're also allowed to do reciprocals of variables if you want to. If I have x, the reciprocal of that would be 1/x. If I have something like a/b, the reciprocal would be b/a. So you can use variables within reciprocals if you need to. The mathematical properties of these numbers will work whether you're talking about a number or a variable. There are going to be 12 properties that we learn all together in this unit. And the first 4 I have listed here: additive identity, multiplicative identity, additive inverse, and multiplicative inverse. I have their descriptions right here. So what I want you to do now is pause the video, make sure you're taking notes about this. So I would just draw this, this diagram. We're going to be doing 12 properties total. So I'm going to put them up here 4 at a time. We'll talk about the description, and then I'll give you examples of each one. And then we'll do some examples of all 12 of them together to try to distinguish between them. So pause the video and write those down, and then we'll get into the examples. Okay, to give you some quick descriptions of these properties, we're going to be doing 4 at a time. So additive identity is the first one. Earlier in the video, we said that the additive identity element is 0. And basically what that means is any number that we add to 0 is going to give us that number that we started with. And that's basically what the additive identity property states. Any number added to 0 is itself. So we can have something as simple as 5 plus 0 equals 5. We could have that switched around. You could have the 0 first. We could use variables, so something like 0 plus x equals x. Anything plus 0 is itself. You could also have a mathematical expression added to 0, like a plus b plus 0 is a plus b itself. So there are a whole bunch of variations of additive inverse that you could have. Multiplicative identity property. The multiplicative identity element earlier we said was 1. So any number multiplied by 1 is going to be itself. It's very similar to the additive identity property, but the difference is we're using multiplication now and the multiplicative identity element 1. So very similar to these. An example, 5 times 1 equals 5. We could have something like x equals 1 times x. The 1 doesn't have to be on the left, just like over here the 0 would not have to be on the left, it could be on the other side. We could have something like 1xy equals xy. So anything times 1 is itself. The third property is the additive inverse property. And in the additive inverse property, in the last video we talked about when we were doing the real number system, we talked about opposites when we did the real number system. When we started talking about integers, we said that the definition of integers was the set of whole numbers and their opposites. The set of whole numbers was 0, 1, 2, 3, dot, 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 and then the opposites would be the negatives of those numbers, okay? So if you're talking about additive inverse, basically what that means is if you add a number to its opposite, you're going to get 0. So a real simple example of that would be -5 plus 5 equals 0. Any number plus its opposite is 0. X plus -x equals 0. Xy plus -xy equals 0. Okay, those are all additive inverse properties. And then the last one in this section is the multiplicative inverse property. And earlier in the video, we talked about what the multiplicative inverse is. That's when we flip a fraction upside down. It's the same thing as a reciprocal. And basically, the multiplicative inverse property states that any number multiplied by its reciprocal or by its multiplicative inverse is 1. Remember, we can use reciprocal and multiplicative inverse back and forth. They mean the exact same thing. So basically, that property would be something like this. 3/4 times 4/3, its reciprocal, is equal to 1. And you could do that math real quickly. If you were to multiply a fraction or two fractions together, you multiply the numerator, multiply the denominator. So 3 times 4 is 12, 4 times 3 is 12, so you'd end up with 12 over 12, which in fact is 1. Okay? You could have something like that in variables. We could say a over b times b over a is equal to 1. It could be more complicated than that. We could say a plus b times 1 over a plus b equals 1. Those are all examples of the multiplicative inverse property. I have the next 4 properties up, so at this point I want you to pause the video. Let's talk about each of these examples or each of these properties that we have here. The multiplicative property of 0 basically states that if you multiply any number times 0, then you're going to get an answer of 0 because anything times 0 is 0. So they made a property out of that. It's very simple. 5 times 0 equals 0. You might have something like 0 equals 0x, okay? They may try to make it a long string of different numbers, like they might do 2 times 10 times -8 times 5 times 0 times 8 equals 0. It doesn't matter how many numbers you have in there. If you multiply all of those numbers times 0 anywhere, then the whole thing is going to be 0, okay? The next one is the associative property. The associative property is not real difficult, but it is an easy one to get mixed up with something called the reflexive property, which we'll learn in the next section. So the associative property, basically, the things you need to know about that, okay? The order of the numbers will be the same if it's an associative problem. Okay, the order of the numbers is not going to change. What changes is where the parentheses or where the grouping is located. So the numbers are going to be in the same order, but the grouping changes. Like the parentheses might be around the first two numbers on the left side, but then around the last two numbers on the right side. So if it's associative, the only thing that's going to change is where the parentheses are located. And the associative property only works for addition and multiplication. It won't work for any other operation. So an example of that, and I'll just do a real simple one. If I have something like 2 plus 3 plus 8, then that, with the associative property executed, would be 2 plus 3 plus 8. Now if you look at that, notice the order of the numbers on the left-hand side of the equal mark and the right-hand side of the equal mark have not changed. The order 2, 3, 8, 2, 3, 8 has stayed the same. But notice 2 plus 3 was grouped here. The 8 was on the outside. And over here, the 3 plus 8 is grouped. So your parentheses have moved. The order of the numbers don't change. The parentheses have moved. Okay? Another example of that would be something like this. X times yz equals xy times z. In this one, your x, y, and z order has stayed the same, but the grouping has changed. On the left, the yz was in parentheses, and on the right, the xy is in parentheses. So the association or the grouping has changed, okay? The next property is the commutative property. This one also only works with addition and multiplication. But in this one, the order of the numbers do change. So the order of the numbers is going to change in the commutative property. And those numbers are going to change across an addition or multiplication sign. Now, this property is one that kids get mixed up with the symmetric property, which again we'll learn in the next screen. So the commutative property, the big thing here is order does change, but it changes across addition or multiplication, okay? So, for example, if I have something like 5 plus 6, that would be equal to 6 plus 5. Notice we have the same numbers, but the order of the numbers have switched across that addition symbol. Okay, so 5 plus 6 is equal to 6 plus 5. I could do this with multiplication. Xy equals yx. Okay, those numbers, or variables in this case, have switched across a multiplication symbol. They're switching across the symbol that's in between them. So x times y equals y times x. They've switched across that multiplication symbol. All right? And then the next one is the distributive property. In Algebra 1, you should have become really familiar with the distributive property because there are so many uses for it. You can't solve very many equations in Algebra 1 unless you know how to do the distributive property. And then solving expressions, there's so many things you do with the distributive property. But basically, if you have the distributive property, you should already know how to recognize it. But you'll have a number outside a set of parentheses, and that number on the outside will multiply by everything on the inside. So a real simple example, if I have in parentheses x plus y, and on the outside a 2, if I do the distributive property, I'm going to take that 2, it's on the outside, and I'm going to multiply it by everything on the inside. So that is 2x plus 2y. Okay, so that's a very simple example of the distributive property. Okay, here are the last 4 properties in this section. So I'm going to ask you to pause the video and go ahead and draw or write down the notes, and then we will talk about specific examples of each one. The reflexive property, the description of that is whatever is on the left-hand side of the equal mark is exactly the same as what's on the right-hand side of the equal mark. So there is nothing at all that will change from the left to the right. So we might have something as simple as 5 equals 5. That is the reflexive property. You may have something like x equals x. Or we could say 1x equals 1x, and there is nothing different about it at all, okay? Where they will try to trick you sometimes is they might do this. They might say 5 plus 2 plus 6 equals 5 plus 2 plus 6. If you notice that, we have something grouped here, and then the same thing grouped on the other side. Nothing from the left to the right of the equal mark has changed. The parentheses are in exactly the same spot. A common mistake for this one is students will see the parentheses and they'll automatically say, oh, that's associative. Well, it's not associative because there is no change in the grouping of those two sides of the equation. So you have to be real careful. That is one of the places where they will try to trick you, okay? For the symmetric property. In the symmetric property, no matter what, you will have two equal marks. Now, this is not the only property that could have two equal marks, but it's the only one that has to have two equal marks in order for it to work, okay? So if I see a problem or an example that has two equal marks, that's going to be the first thing I'm going to look for is the symmetric property. Now, you could have substitution or commutative. They could have a possibility of having two equal marks. I'll show you how later. But if it's got two equal marks, it could possibly be symmetric. It can't be symmetric otherwise. And basically the symmetric means the order will switch across the equal mark. Okay, so you might have something like this. A equals B, so B equals A. Well, that makes sense. We know that if two things are equal, they're also equal if we flip them across the equal mark. Okay, so that's an example of the symmetry or symmetric property. We might have something like 5xy equals 2c. So 2c equals 5xy. Okay, it switches across the equal mark, and there's usually going to be some sort of a qualifying word between them. A equals B, so B equals A, or they might say A equals B, therefore B equals A. Since A equals B, then B equals A. I mean, you could have all kinds of different ways, different language to signify that. The next property is transitive. Transitive is going to always have three equal marks. That is usually a dead giveaway for the transitive property. Okay, and I'm going to show you how they can complicate it, but basically in the transitive property, you're going to have a first, second, and third item, okay? And if they say that the first item is equal to the second, and then they turn around and tell you the second item is equal to the third item, well, it makes sense that since the first is equal to the second and the second is equal to the third, then the first and third must also be equal. So that's the basic transitive property. So it might look something like this. If A equals B and B equals 5, then A equals 5. Okay? So it's real simple. Here's where they might try to complicate it a little bit. They might say something like this. 2 plus 3 equals 8 minus 3, and 8 minus 3 equals x, okay? So 2 plus 3 equals x. So they've made it a little bit more difficult by putting an expression in there, but the basic understanding of the first thing equals the second thing, and then the second thing equals the third. So it's true that the first must equal the third, okay? And then the last one is substitution. And basically in substitution, you are replacing something within the problem with its answer. So I might have something like this. 2 plus 3 times x equals 5x. I have replaced 2 plus 3 with its answer 5. That's an example of substitution. Substitution is another one of those examples that could possibly have two equal marks. I could say 5 plus 3 equals A, so 8 equals A. There's an example using two equal marks. Okay? So there's a whole bunch of different ways that I could present these problems to see if you can distinguish between them. Okay, another thing I want to point out is occasionally you might see an example where you might be able to put more than one property down. Sometimes like in IXL or Delta Math programs like that, sometimes they'll have one that has both properties. In that case, whichever one you choose is going to be fine. Now looking at this one, this times 0 equals 0, that's a multiplicative property of 0, okay? Or we could say, well, that 0 is on the outside, so if I multiply everything by 0 on the inside, I've used the distributive property, okay? So there are some different things you could do with that. So you just have to understand that if more than one property works, that's okay. Look at this one. For that one, 1 times x plus y gives us x plus y. Well, we could consider that to be the multiplicative identity property. But then we have taken this and we have added 0 to it, which is the additive identity property, because anything plus 0 is itself. So with that, there are a couple different properties that I could have used. The other really significant thing with properties that you have to understand is you are only allowed to use substitution as a property answer if none of the other properties will apply, okay? So substitution should only be used if nothing else can be used, okay? Because otherwise, if you think about it, we could use substitution for every single problem, okay? So substitution can only be used if nothing else works. For example, look at this one. 1x plus y equals x plus y. Well, we can't say that 1x equals x is substitution. For that, we have to be more specific and say that's the multiplicative identity property. And then here, 2 times 0 equals 0. If you're not thinking, you could say that's substitution. Anything times, or if we replace something with its answer, we get substitution. But we're only allowed to use substitution if nothing else works. So 2 times 0 equals 0 would be multiplicative property of 0. Okay? And then for this one, 5 plus 7 times x equals 12 times x. There is no other property that tells us 5 plus 7 is equal to 12. That is replacing something with its answer. So it's okay here to use substitution. Okay, so I have 20 examples here. Some of them are more difficult than others. I am trying to trick you on some of them to see if you can distinguish between the properties. So copy them down, try them, pause the video, see how you do, and then we'll come back and check them. I'm sure you noticed that at the beginning I've got some that look very similar to each other, at least they start out the same way. I'm doing that to really make you focus on what is changing between the left-hand side of the equal mark and the right-hand side of the equal mark. If you can do ones that are very similar to each other like that, it makes all of them a little bit easier in the long run. So here I've got 2 plus 5 plus 8, 2 plus 5 plus 8. Order did not change. The parentheses are around the same thing. That is exactly the same on the left as it is on the right. So that would be reflexive. I'm just going to put the properties right there beside them. Number 2, 2 plus 5 plus 8 equals 5 plus 8 plus 2. The order there has changed. There's only one equal mark. The grouping has not changed. The parentheses are still around the 5 plus 8. So that one is the commutative property. And you could be specific, that is commutative, the commutative property about addition. When you take standardized tests, usually they want you to specify what the operation is, but that's pretty simple. The plus sign gives away which one it is. It will either be addition or multiplication. You can't have both, and you can't, commutative does not work for subtraction or division, only addition and multiplication. Number 3. 2 plus 5 plus 8 equals 2 plus 5 plus 8. The order did not change. If there's only one equal mark, the grouping has changed. The parentheses have changed across that equal mark. So that would be the associative property. Be careful with your abbreviations. Please make sure that you don't have any bad words on your paper. With the next one, 2 plus 5 plus 8 equals 7 plus 8. We've got 2 plus 5. I've added that together to give me 7. So I've replaced something with its answer. That is substitution. In the next one, this one has changed a little bit. 2 plus 5 plus 0 equals 2 plus 5. We have added something to 0. That is the additive identity property. Anything plus 0 is itself. For the next one, 2 times 5 plus 8 equals 2 times 13. At first glance, you might try to say that's distributive, but if you notice, we have replaced 5 plus 8 with its answer 13. So that one is, again, substitution. In the next one, 2 times 5 plus 8 equals 2 times 8 plus 5. For that, we have very similar problems, but the 5 plus 8 and the 8 plus 5, that has switched across that addition symbol. So that is, again, commutative. And that's commutative for addition. Addition there because it switches across the addition symbol. Notice that. A common mistake there. I could see people putting commutative for multiplication just because there's a multiplication on the outside of the parentheses, but where the actual flip has taken place, it's across the addition symbol in the middle, or in the parentheses. For the next one, we've got 2 times 5 plus 8 equals 10 plus 16. I have taken the 2 on the outside and multiplied by everything on the inside, so that is the distributive property. This one looks similar to start. We've got 2 times 5 plus 8 equals 5 plus 8 times 2. The 2 has switched across that multiplication symbol. So that's the commutative property for multiplication in this case. Number 10, 0 times 5 plus 8 plus 6 equals 0 plus 6. I have multiplied the 5 plus 8 times 0. Anything times 0 is 0. So that's multiplicative property of 0 for that one. Okay? Let's go over here. Negative a plus b equals 0. Anything plus its opposite is equal to 0. That is additive inverse. Additive inverse. For this one, we've got 2 times 5 plus 8 times 0 equals 0. We have 3 things multiplied by each other, and one of those things is 0. So anything times 0 is 0. That's the multiplicative property of 0 again. For this one, first thing I noticed are 3 equal marks. That's probably transitive, but let's just double check. 2 plus 3 equals 10 over 2. And 10 over 2, the second thing, equals the third thing, 12 minus 7. So 2 plus 3 equals 12 minus 7. That is the transitive property. That 3 equal marks tends to give that one away. 14. This one has 2 equal marks. Okay? So it's possible it could be symmetric. I'm going to look for that first. It says 8 plus 3 equals a plus b. So 11 equals a plus b. Well, that's not symmetric. If it was symmetric, then these two sides would switch. The a plus b would be on the left, the 8 plus 3 on the other side. So that's not symmetric. It's got to be something else. Let's look at what's really happened here. I have replaced the 8 plus 3 with its answer 11. So that would be substitution. I've replaced something with its answer. This one also has 2 equal marks. 8 plus 3 equals a plus b. So a plus b equals 8 plus 3. It does look like that has switched across that equal mark. So that is symmetric. Number 16, xy equals 1 times xy. Anything times 1 is itself. That one's backwards from what we're used to, but that is the multiplicative identity property. For this one, 4 plus 8 plus 0 equals 12 plus 0. That one's tricky. A lot of people might look at that and say additive identity, but we have not added anything to 0 and gotten itself See, that's not additive identity. What we've done here is we've replaced 4 plus 8 with its answer 12. So that's actually substitution. 4 plus 8 plus 0 equals 0 plus 4 plus 8. Again, at first glance, you might try to say additive identity, but that doesn't apply here. If it was additive identity, over here we would just have 4 plus 8. But what we actually have is these two numbers have been flipped across that addition side. So that again is the commutative property. You don't see that very often with 0. They don't usually do that, but it's good for you to see how that might look in an example. 19, 1 equals 5 times 1/5. 5 and 1/5 are reciprocals or multiplicative inverses. So that's the multiplicative inverse property. And then for this one, the x is on the outside. You've got y plus 2 on the inside. I'm going to take the x and I'm multiplying by everything on the inside. So x times y is xy. X times 2 is 2x. So that is the distributive property. Okay? And that completes our lesson on properties.